Assalamualaikum warahmatullahi wabarakatuh, and a very good day to our lecturer, that is Dr. Nordin Sabli, and also my fellow friends. Today I will share about thermodynamic subjects, that is about first law of thermodynamics and also second law of thermodynamics. So let's get into this topic. Okay, on the history of the first law of thermodynamics is founded and discovered by Rudolf Clausius. So he's found the first law of the thermodynamics by in the issue of the thermodynamics processes. So thermodynamics processes have three types of processes. The first one is about cyclic process. So cyclic process is when a system in a given initial state goes through various processes and is finally returned to its initial states. So therefore the system has undergone a cyclic process or cycle. For the second processes is about reversible process. It is defined as a process that once having take place, it can be reversed. In doing so, it leaves no change in the system or boundary. So the last one is irreversible process. There is a process that cannot return both the system and surrounding to their original conditions. So the definition of the first law of the thermodynamics is the energy is always conserved. It cannot be created or destroyed. So in another part, it can be converted from one form into another. So you can see in the right part of this slide, it's some of the energy conversion. There is about the first one is the chemical energy when you consume food, and then it can be returned or convert to the mechanical energy, or also using of the battery that is chemical energy. You can have a you can have light energy in the torch for the torchlight. So also by using light energy from the sun, we can have the chemical energy for the plant to have the photosynthesis. And for the electrical part, you can use the electrical parts in order to get the light, to have the lamp, to turn on the lamp. Also for the chemical energy, you can use some gasoline or oils in order to have a movement in our car. And also when we are using electrical supplies, it converts into some of the heat energy. So this is the formula for the first law of the thermodynamics, that is Q minus W, or before that Q is movement of heat minus W. W is work, equals to delta U, that is the internal energy, change in internal energy, final minus initial, plus kinetic energy, that is maybe the system have some movement, so we need to take into account of this value for the velocity. If they have change in velocity plus the potential energy, if the system or the condition of the issues have change in maybe height or some length. So in the right parts, you can see there are four conditions that we must account when we are using the first law of the thermodynamics. So the first one is when we have constant volume, or we call it isovolumetrics. So the W, or work done, is equal to 0. Sorry. For the second part is about constant temperature, or we call it isothermal. So the delta U, or the change in internal energy, is equal to 0. Next is no heat transfer, or we call it adiabatic. So the Q, the heat transfer, is equal to 0. And that's all. So before we continue to calculate or to account our issues related to the first law of thermodynamics, we need to ensure that the issues such as isovolumetric, isothermal, we need to account that, and then alert on the condition given, so that it will ease our calculations, and we can simplify our general equation into an easier parts. So the next part, other than the issue or condition that we need to account in our calculation, is we need also to take care of the sign of the work done, also heat flow. For example, you can see in this diagram, we can see that when the work done on the system by the surrounding, so the W is positive. So when the work is out from the system, so the W is negative. Same goes to the heat flow, right? Next. So we are moving the next part. So it's easy to remember by like Q and W. So we move to the right. So in the middle is the system. So when the Q is come into the system, it will become positive, and also when the W is move from the system, so it will also positive. Sorry, this slide is a little bit wrong from the sign. It's supposedly work out is positive. I'm sorry on that. So these are the application for first law of thermodynamics. So I'm using a heat engine as the example. So heat engine use the properties of thermodynamics to transform heat into work. So examples such as gasoline and diesel engines, or jet engines and steam turbines that generate electricity, are all the example of the heat engines. So the right part of this diagram I will explain in this part. So for the part A, we can see that heat transfer to the gas in a cylinder increases the internal energy of the gas, creating the higher pressure and also temperature. So for the B part, the force exerted on the movable cylinder does work as the gas expands. So the gas pressure and temperature decreases during expansion, indicating that the gas's internal energy has decreased as it does work. So for the last part, we know that heat transfer of energy to the environment further reduces pressure in the gas, so that the piston can more easily return to its starting point. So that's all for the first law of thermodynamics. So we move on into the second part, that is second of the thermodynamics. So for the second law of thermodynamics, it is discovered by Sadi Carnot. So the story of it is Sadi Carnot used current form of the second law, uses entropy rather than caloric to describe the law. So caloric relates to heat, and Sadi Carnot realized that some caloric is always lost in the motion cycle. Therefore, the thermodynamic reversibility concept was proven wrong, proving that irreversibility is the result of every system involving work. So these are the equation for the second law of thermodynamics, that is delta S, that is entropy, is equal to the delta Q, that is change in heat flow over the temperature. So there exists a useful thermodynamics variable called entropy, a natural process that starts in one equilibrium state and ends in another will go in the direction that causes the entropy of the system plus the environment to increase for an irreversible process and to remain constant for a reversible process. So the definition of the second law of thermodynamics is energy exchanges. If no energy enters or leaves the system, the potential energy of this state will always be less than the initial state. So this also referred to entropy. So the application for the second law of thermodynamics, I take into example, that is the first one is ice cubes. So the ice cubes in a drink absorb heat from the drink, making the drink cooler. If we forget to drink, after some time, it again attains room temperature by absorbing the atmospheric heat. All this happens as per the first and second law of thermodynamics. So for the second part, I take into example, that is about the air conditioner. So the air conditioner and heat pump follow the similar law of the thermodynamics. The air conditioner removes heat from the room and maintains it at a lower temperature by throwing the absorbed heat into the atmosphere. The heat pump absorbs heat from the atmosphere and supplies it to the room, which is cooler in winters. So that's all from my presentation in the first law and the second law of thermodynamics. I'm sorry if some of the example or needed subtopics in this law does not included in my presentation, since maybe I missed some of the important things. So I'm sorry on that if I'm not included the needed thing or fundamental, or I'm just sharing the basic things. I'm sorry on that. So that's all for me. Thank you.